Hola.
Hola.
Hola. Llamo a esta charla Iteración, la historia secreta. Pero de verdad no es historia secreta, pero desconocida. Yo, as Mariela said, I still don't know how to say chair of the Python Software Foundation. Anybody knows how to tell me how to say that in Spanish? Pardon me? Director.
Jefazo.
Whatever, okay. And of course, author of the Quick Python book, and we will be giving some more of those out. I do want to say that this signing we're doing, I'm really happy about. It's the first time that they have done this for me. So I'm really happy that my first time is here with you. So, I also lead a team of Python developers for a company called Dick Blick Art Materials. We sell artists' supplies. It's a lot of fun. I do just want to say, just Python Charles, Python Charles, Python Charles, Python Charles. Eso es todo. Okay. Again, for as far as the PSAFA goes, please join us. There are stickers. You saw people crowding around to get the stickers. Mariela has stickers if you sign up as a basic member. So they always work. I tell people, no, believe me, they always work. And finally, yes. Yes, I love Cecilia Suarez. I love Paulina de la Mora. I love Casa de los Flores. But I also have to say that I don't think I could even begin to talk about a technical subject in Spanish. But it is a goal of mine one day to do that. So you've heard it here first. I'm committing now. So you have that. So on with the rest of the talk then. So I'm talking about iteration, which basically is repeating code that repeats itself on data that repeats itself. Repetition with code and with data. Now what I'm going to tell you about is what Dave Beasley, my friend who's also from Chicago, has called Python's most powerful, useful feature. The way that Python does iteration. And I recommend to you, there's a talk, and I will post these slides later, but since I'm going to be live coding, I can't post them now because they're not done yet. So I will post the slides later, but I recommend his talk. He's got Iterations of Evolutions, the unauthorized biography of the for loop. It goes deeper into the history of this than I will. Plus, he also plays the Monty Python song on his trombone, which you will see nowhere else, I promise you. So I do recommend Dave's talk. So, much of what we do as programmers involves repetitive collections, series of data. We want to do the same thing with a whole bunch of things that are basically the same in line. We do this, we do it with this, we do it with this. It could be temperatures for a month, if you are studying the weather. It might be dictionary keys and their objects. It might be a CSV file of 1 million products. I have done that. It might be the text of some big novel or some big chunk of text. Maybe it's 1 million tweets, whatever. You know, it's a lot of text. It might be the results you get from querying a database for yesterday's sales. It could be any of those things, right? Those are just common examples. And the thing is, all of those collections of data are really different types. They're not the same type. They're not all lists. They're not all dictionaries. They're all different things. And they contain different types of objects. A database record is different from a string, is different from a dictionary element. So they're all different types, but we want to do the same thing with them. And we want that to work the same way. We go through one, so on, and so on, and so on, all the way to the end. So that means we use a for loop. And see, I'm going to be live coding, so you need to watch me to make sure I don't make any mistakes. Or I guess you can watch and wait until I make a mistake, whichever, I don't care. But, so this is pretty easy, of course. We'll just do right? And we get that. So obvious. It's one of the first things we learn. And it works no matter whether or not that thing that we give the for loop is maybe a dictionary, or a string, or query results, or a file. It works the same way. And it is so common now that it is obvious, except it was not always obvious. So, to go back in history, this is nearly 25 years ago. The documentation for Python 1.1 says the for statement in Python differs from what you may be used to in C or Pascal. Rather than always iterating over a progression of numbers like in Pascal, or leaving the user completely free in the iteration, test, and step as in C, Python's for statement iterates over items of any sequence in the order they appear. This was so different that it gets a special mention in the Python documentation as, you won't expect this, but this is what happens. Okay? But, okay, so it's obvious, so it's all of these things, but it does raise a few questions, doesn't it? Like, how does a for loop know what's next as it's going through all of these different sorts of series, and how does it know when to stop? How is it for loops work with all of those different types, even types that Python doesn't know about until you actually define them? How does it know? And if I want to define, if I want to create my own object to use in a for loop, how do you do that? Well, the answer to all of those things is what I'm going to talk about. It's the iteration protocol. And it is a protocol, which means that if you do what the protocol says, if your object behaves the way that the protocol says, it will work for iteration. It's not types, it's not anything that is hard-coded. And it has been, this protocol has been defined since Python 2.2, which is pretty darn old because I started, it basically is like a few months after I started Python. I started Python on 2.1 and 2.2 came out. This is like the end of 2001 that this became set as a protocol. And the other thing about this protocol is that it's a very good example of what we mean when we say duck typing in Python. You've all heard the phrase? Yes, no? Duck typing as in, if it walks like a duck and it quacks like a duck, it's a duck. So if an object behaves a certain way, we don't worry about whether or not it's exactly the object or not, we just go with it. Unlike Java, where if it's not exactly the right type of object, the whole world ends. We just do it, right? No offense to people who love Java. I just one little dig. No more, I promise. Okay, so so if anybody asks you, what's this duck typing thing in Python, you can say, well, one example is the iteration protocol and how for loops work with all sorts of different objects. So there are two pieces that you need to make the iteration protocol work. First of all, you need an iterable object. That's item number one. And they helpfully made the words very similar so that it takes a while to keep from confusing them. But you need an iterable object, and I'm going to show you that in a second. And then you also need an iterator. And the thing about the iterator is that you don't always see it, because quite often Python handles it for you without telling you. This is sort of the secret part of the secret history. So, what is an iterable? Start with the first piece. An iterable is an object that can return its member data pieces one at a time. Okay, so far so good. It can be a class that has a dunder-iter method. Okay, or it could be a class that has a getItem method that implements sequence semantics. I'll explain that in a second. And what that means is that all iterables are all sequence types like lists, strings, tuples, all of those. And also some things that are not officially sequences, but they do have a dunder-iter method that makes them into iterables, so that's the way that we can do dictionaries and files and things like that. Okay, so two pieces. Now, I said that one of them was using getItem with sequence semantics. I want to be sure we all agree what that means. So what that means is that you can access the items in order using square brackets and an index starting from 0. So you get item 0, item 1, item 2, item 3, etc. That is sequence semantics. And the other thing, as far as Python's sequence semantics goes, is that when you get past the end, once you have gotten to all of the items and there are no more, and you try the next index, you get an index error is raised. Okay, this is important. So those are the pieces. So as I say, if I have a list X with 3 items in it, I can do X0, X1, X2. I try to do X3, I get index error. Okay. And I'm gonna say a few more things about iterables before we look at what really is an iterable. But if you do have an iterable, then you can use it in a for loop to go over the items in that iterable. You can use it with functions like zip, map, all of those things. You can use it in comprehensions, various things. And if you call the iter function on it, it will return this thing I talked about, the other piece of the puzzle, an iterator for that iterable. We're going to revisit this a few times, so it will, I hope, be very clear by the end. And the thing is that in a for loop, like the for loop I did with a list, and I iterated over that, you saw the iterable, that was the list that I iterated over. You never saw the iterator because in a for loop, Python creates it for you, doesn't give it a name, uses it behind the scenes, and throws it away once the loop is done. So it's there, you just don't typically see the iterator part if you're doing a for loop or a list comprehension or something like that. Okay? So, as I say, iterables must return an iterator when you call iter on them. And that can happen in 2 ways. Again, this is review. Happen in 2 ways. One of them is getItem, sequence semantics, as I just said. The other one is it will have a dunder-iter method that returns the iterator for you. So we got that. And of course, in Python, we believe it's easier to ask for forgiveness than for permission. So how is it you find out if something is an iterable? Excuse me. Well, the easy way is to call iter on it and see what you get. Okay? In other words, like for example here, If I call iter on the list 1, 2, 3, I get a list iterator at that long location that I can read. Okay? If I call iter on something else, like this case, let's do it on there, I get a very clear exception telling me, no, this is not an iterable. So that's how you would tell. It's really very hard otherwise, because if it's something that implements sequence semantics, you can't just look at it and say, oh yes, that's sequence semantics. So that's what you want to do. So what I want to do now, and yes, this is the dangerous part, because I'm going to do some live coding that's more than just printing out a list. But I'm not afraid. I want to do a very, very simple iterable. I'm going to make it from nothing. And it's going to be so simple, it will return the same value every time. So I don't need to think about what it returns. And then we'll just tell it how many times we want it to be iterated over. So if I say, I'm going to make this repeater. If I say repeat hola 4 times and put it in a for loop, that's what I will get. Okay? Everybody clear on that? It's meant to be like the simplest possible thing I could think of to do. Okay, and the way I'm going to make this an iterable is I am going to implement it using getItem with sequence semantics. So you'll see what I meant by that. So what do I need to do? Well, so first of all, I suppose I should save these values, these parameters. Yes, so. All right, so that actually stores what I'm going to be using. That's easy enough. Now, I need to implement sequence semantics. So, remember what I said. I said that you start from 0 and you go up until you're past the end of the list, and then you return index error, right? That's what we need to implement. Okay, so if equal to, so if I am at 0 or on up, so that, and I am less than my allowed number of things, right? I want to return the value I'm repeating. Okay? Catch me if I make any mistakes. I might throw one in later on just to see if you're watching. You never know. And if we're past that, if it's not 0 up to that range of items we've got, we want to raise an index error. Okay? Now, this is what I said we needed, right? I said we needed to implement sequence semantics. That pretty much does that. So I'm going to go ahead and do that. So now, here's your first test of faith. Do you think that this will work? Don't answer. Don't answer. I don't need you to. So I'm going to give it a try. I'm going to make. Come here. So apparently I didn't get an error. That's good news. So let's see. Let's see what I can do. So I've got repeat. So let's see if I try to get the first element using sequence semantics. That would be this, right? Okay. So let's try the last element. As I said, it's going to have 4 elements. We start from 0. So. Okay. Let's get the next item. Let's go on past. Let's try 4. You know what should happen? Index error. So this does what I said was sequence semantics, yes? But the other thing, the real test in a way, was if I call iter on it, do I get an iterator? So let's try that. Are you still with me? You still believe? Okay. I get an iterator. Okay, fair enough. I mean, we've apparently implemented an iterable. So now this is the real test. Can we use this in a for loop? If you're doubting me again, don't tell me I don't need to. Okay, think it's going to work?
Yes.
All right. I've had times where people go, no. Yes. That is an iterable. That is all that there is to an. I know now you're all going to go away like, oh, I thought it was something. So that is an iterable. I mean, I wonder if, like, let's just see to make sure here. So let's try a list comprehension. Yeah, that works too. Yeah, I think we actually have an iterable here. So what happened there is, again, these are the pieces that I laid out for you. At least this is the first half of the story. Is that the repeat object we made, the repeater class that I defined, implements the iterable part of the iteration protocol. It is an iterable. It can return its items, 0, 1, 2, 3, etc., up until the end. When it gets to the end, it throws an index in. Okay, what we did not see in either of those cases is that an iterator was created from the repeat object when we put it in the for loop or put it in the list comprehension. And this sort of anonymous, unnamed little temporary variable actually held the iterator. And it was apparently that thing that caught our index error so that we didn't have an exception being thrown when we actually run the for loop. I mean, obviously, every time you run a for loop, having the program crash because it raises an exception is no good. We have to handle that. So that's what happened. And then you also saw that I could repeat it. So like I used it in a for loop, I used it in a list comprehension. That is, every time I used it that way, I got a fresh iterator that was used for that cycle of iteration and then thrown away. This is an important distinction coming up. That's why I'm calling it out. Okay, so we got. That brings us to the second part. Because I have been talking about iterators, but what is an iterator? Okay, how can you do that? Because after all, if you're doing iteration, you're doing a for loop, you're doing any of these things, the for loop has to know what's next. The for loop itself doesn't have any way of knowing what's next. It's not like a C for loop. For those of you who see, you actually know what's being next because you specifically have it incrementing the counter or something like that. Python for loop itself doesn't know what's next. The iterable clearly does not know what's next. You saw what I put in the iterable. It was almost nothing. Okay? So we need the iterator to keep track of what is next. Okay? And in fact, that's one thing that an iterator needs to have is a dunderNext method. Or in Python 2, for reasons I've never known, it's just plain next without the double underscores. But it needs to have that and keep track of what is next, and then each time it is asked what is next, return the next item. So this is the part that we haven't really talked about. So, to kind of rephrase it, and I'm gonna say this a couple of different ways. So an iterator, of course, it's a stream of data then. Each time an iterator's next method gets called, you get the next item. When you get to the end, it's no longer a stop, it's no longer an index error, excuse me. It's a stop iteration exception that gets raised. And we'll see this in a moment. And the last thing about all of this is that iterators are meant for one cycle only. You can go through, iterate, go to the end. When you get to the end, it's exhausted, and every time you hit next on that iterator, once you've gotten to the end the first time, you're always going to get the stop iteration thing back. You're never going to have a new thing. This is different from the way iterables behave, where iterables, when you call iter on it, you get a new one, you get a new one. This one, once it's used, it's kind of done. So, the last thing that we need to say is that, by definition, all iterators must have a dunder-iter method that returns the object itself. Okay, remember, having a dunder-iter method is one way you make something an iterable. So that means, this is where it gets sort of like, oh no. That means that all iterators are also iterables. Perfectly simple. Everything's the same except when it's different. So you can use an iterator. In most places you could use an iterable, like in a for loop, in a list comprehension. Except there is one catch, and you can find people, particularly people who are new to Python, will make this mistake and they do not know what is happening to them. And that is, again, I said that iterables you can reuse because every time that iter is called on them, they get a fresh iterator and you can go through and do it. With an iterator, when you call iter on it, it just returns the object itself. If that object has already been used and you put it in a for loop, it's going to look like there is nothing in it because it's already been used up. So this is the thing that catches people. They use their iterator. Like maybe they have a file iterator. You read all the way through the file. And then they're like, oh, wait a second, I want to do something with it again. And they use the same thing. It's like, what? The file's empty. No, you have to get a fresh, instance. You have to get a fresh iterator for it to work. So, to show you what this does, I'm going to step through the same thing that we did before with my repeater, except this time I'm going to make it an iterator, not an iterable. Well, it is an iterable because by definition all iterators are also iterables. But we're going to do the iterator approach here, okay? And that means we need to do two things. We need to implement a dunder next to return the next item, and it better have a way of keeping track of the next item. It better know what is next. And then we'll make a dunder iter method that returns itself. So here we go. So we'll need to do the same sort of initialization, right? But I also want to have a way of knowing where I am in my repetitions. So I'm going to use count. So when I start, it's going to be 0. Okay. Now I need to have a way of just tracking, making sure I don't do too many or too few things, right? So I'm going to say, if my count is lower than my limit, I must be okay. So let's do that. And yeah, since it's, that will be fine. So let's say we do count is less than self.limit. Okay. I need to return my value, of course. But before I do that, I'd actually better take care of keeping track of how many times I've iterated. I saw some of you there looking. You were waiting for this, so yes. So we need to add 1 to our count each time we actually return something so that we know if we're asked for 4, we only do 4, not 5, not 3. 6 is right out. So we do it right. So, okay, so we do that. And then the other thing we need to do is iter needs to return the object itself. That's not too hard, actually. We do that. Okay. Yes? Pardon me?
I'm missing an if.
I'm missing an if? Oh, thank you. The rest of you are just going to let me walk into that, I know. But we're friends, so he caught it. That's good. All right, yes, thank you. Anything else? All right. Are we all believing this will work? Well, let's go ahead and see if I've got a syntax error. That we have, apparently, we're fine. So, I'm going to just make a copy of this that says hi 4 times, and then let's just see what we get. So, let's do that. Okay, we have a repeat iterator object. Of course, that doesn't really mean anything since I called it repeat iterator. I mean, that doesn't really mean it's an iterator. We need to see what's going on. But at least we've got an object. That's something. So, next thing I want to do is see if I can use the next function to get a value from it. If this is an iterator, I should be able to put next on it and get the next value. So let's see. Still think it's going to work? Oh, you're no fun. Okay. So we got one. Amazing. Now, here's where I want to go back to this whole thing that when you call iter, which is what you would do in a for loop or anything like that, on an iterator, it returns itself. So, basically what I want to do there is just sort of make the point, here I printed the iterator itself, and I got this, oh, it's a repeat object at blah, 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 blah. You can look at that number. And then this other time here, I made another variable called iter on my repeat iterator object and stored that in another variable, and I printed that out, and I hope you're convinced they are the same thing. Okay? Again, and the reason I'm doing this is that I want to contrast that with what happens when I take my old repeat iterable that we made at first. That was an iterable that had no iterator in it at all. If I call iter on it, let me show you this. I get, and you have to kind of wade through all of the various letters, but I get 2 separate objects, and every time I call it, I will get a separate iterator object. So that is, again, just kind of circling back to make sure we've got that totally clear as to what happens. So, now the question is, can we use it, this repeat iterator, in a for loop? And back. Make sure I remember what I called it. So, okay. So, can we do this? Okay? You should have some expectation of what's going to happen. So let's see what happens. Ah, indentation error. See, I told you I was going to make a mistake. You missed that totally. Whoops. Uh-oh.
Index error reception missing.
Yeah, I think this is the part where I will use my standard system. When live coding, when something goes wrong, you pretend that you planned on it all along, and then you change the subject. So I had better actually restart the kernel here because it's going to be unhappy with this. All right, let's go down and see what I did. Yes, somebody was saying I forgot to raise the exception here. Quite right. So, go back here. And let's go back into slide mode. Come on. There we go. Now it seems a little bit unhappy with this. Okay. This may be where I continue by means of interpretive dance. Because I seem to be having some issues here. Ah, there we go. Looks like it kind of came back to life. So let me go. The mistake that I made was right here, where I should have said else. Let me see now if I can actually get this speaking again. Come on, come on. Ah, all right. There we go. Trust me, the interpretive dance would not have been pretty. So here, I need to do what I forgot in all of my pattern, I forgot to do, and I need to do what? Raise stop iteration. That's, I guess it's the good thing about kind of rehearsing because I made this exact mistake last week when I was running through these slides. That's why I knew what was going on right away. But in any case, yeah, we need to do this. So I'm going to do that. And then I'm going to see, okay, yeah, all right. So let's go ahead and create our instance. Yes, we're good. Go ahead and do that. Yes, that still works. So then, that still works. Don't want to do that because I don't have that object. So now we go, all right, so here let's see what happens now. Okay.
It works.
It works, whoa! But let's see what happens if we call next on it again. Okay? What happens now? Well, we can find out. Yeah, we get a stop iteration error. Okay, fine. Then, according to what I've told you, let's do this. Let's for item. So what happens now? Those of you muttering nothing are right. Because the for loop is calling iter on this object, it's getting the same thing back because it just hands itself back. It's already used up, so it immediately raises stop iteration error, which means the loop ends. That's what I just said. So that's the difference between iterator and iterable. And as I say, you'll see people who are new to this whole thing make this and not like, what? This object can't be empty. What's wrong? And that is what's going on. Now, having shown you how to make an iterator as a class, my next responsibility is that I must tell you, don't make iterators using classes. because since Python 2.5, we have had a better way of making iterators. For most cases, it still might be, in some cases you still might need to do it. But in general, there is an easier way to make iterators if you want. And that's with a generator function. So, I'm going to show you this really quickly. You're probably already familiar with it. So what I'm going to do is just implement this as a generator. And the thing that makes a function a generator function is using yield instead of return. So that pretty much is the same thing as my class. And the thing about generators is, and I've actually put in this extra step to illustrate it, is that with generators, it looks like you're sort of going into, this function is behaving very weirdly. It doesn't behave like other functions. That's because in Python, a generator function returns an object that then gets used. So it's not as though you're actually continually using this function. You're using the generator object that you make with the generator function. And as it happens, these generator objects are themselves iterators by definition. So if I do this, basically this middle step here you would quite often leave out. And instead you just put the call down in the for loop. You just do repeat gen.3 down in the for loop. I broke it out specifically to make clear that what we're doing is we're making an object and then we're using that object as an iterator. Okay? So, let's see. Did I make any mistakes? Somebody help me out. I think I'm okay. Safe to go? You sign off? Okay. So there we go. And, we could do something like here. We could do that to actually show we've got a generator object that we're using and all of that. But that is the way, usually using a generator function is the way that you would do this rather than making the class. The class is just a way to illustrate what goes on behind the scenes. And so basically what happens is that repeat gen object is going to be what will actually sort of store the state, and every time there is a yield, it returns a value, and then the next time that next is called on it, it goes back in right where it left off and repeats again. So for people who are new to generators, once you're used to generators, like, yeah, this is fine. For people who are new to generators, this is a little bit of a surprise. So that's why I just actually kind of want to revisit that. That's the way that works. So yeah, behind the scenes, we made a generator object, treated that as an iterator, and it just sort of remembered where it was calling the range thing each time to come back. I've heard yours. Okay, so, or of course we could do the same thing with the generator expression. I could do that. That would turn out to be the same thing. And again, I just kind of grabbed it as a separate object. Quite often you just throw it in the for loop. Let's see, did I do that right? I think so, yeah. So it's the same idea. Behind the scenes, the code is very, very similar. If you actually disassemble it into the byte codes, there is a little bit less going on with this version because it doesn't have the function call stuff. So, in fact, if you're obsessed with the very last nanosecond or whatever, the generator expression will be slightly faster. I do classes sometimes and there are people who are obsessed with the last nanosecond, so it is slightly faster. But it's also much more, it's simpler, it is not as flexible as doing the whole function. So quite often you end up needing to do the function. And no, I don't want to talk about 572, if you know what that is. So again, same thing with the generator expression as a generator function. The code, as I say, is very, very similar that is generated for both of them. So that kind of gets us through all of this stuff. And so again, all of those things that I was talking about before, all of those sorts of things are really iterables in this world. And again, we're talking about then what is a protocol, something that is a way that objects behave rather than what exactly they are. Again, we need an iterable to iterate over, and we need an iterator to keep track of what's next. Sometimes they can be both the same thing. But if that's the case, if we're actually using that, then that will be a one-time only sort of process. So that's it. I mean, really, that is the whole story now. You now know the entire secret story. And as I say, I'll post this online so you can look at these if you want. Again, I highly recommend Dave Beasley's talk. But that's really what I have. So I hope that you found this illuminating. Any questions? Yes, sir.
So just for the sake of clarity, a generator is an iterator.
Yes.
And then an iterator is an iterable.
Yes. You got it. That's what I mean. Everything's the same except when it's different. It's perfectly simple. Yes.
And when is it convenient to use like either generators or create an iterable instead of just going over folders?
It might be that there is, I mean, part of this is that most of the common use cases have been covered. So in a large number of cases, you wouldn't really want to do anything beyond what's there. One use case that they mention in the Python documentation is creating your own iterator to iterate over a file and then filter out certain lines. Let's say maybe you want to get rid of empty lines or something like that. It's again, there are other ways of doing it quite often because we've been around, you know, the whole process has been around so long that many of the things you would think of are already covered by, well, iterators. So if you go to the iter tools in the Python standard library, there are a whole collection of iterators that are already made. Like, well, actually it's built-in function. Range is an iterator. So in fact, when I was demonstrating how to make an iterator, I was using an iterator. And there is in iter tools, there is a repeat iterator. Again, doing exactly what I was doing with mine. So, you know, all of those things, there are a lot of them that are there. So I would say in many, many cases, if you find yourself just like secretly desiring to make your own iterator, stop and think, there's probably something already done that you don't have to write. But, so yeah, it's hard to say generally, but there are occasions where it's some collection of data that nobody did that for.
Is it faster? Is it faster?
Is which faster?
Like if you need to do some data transformations and you want to do a generator, is that faster?
I haven't actually checked. Generators in general are slower than other methods, so my guess is that if you did your homemade iterator versus a generator, it would probably be like a few % faster. Because if you do, and I have occasionally done this whole, like do a list comprehension versus a generator expression, the list comprehension is faster almost always. And if you use the map function, that is faster still. But the difference is fairly small. It's like, I think between all of them, it's maybe a few %. Anything else?
Sure.
See, I told you it's like, oh, is this all there is? But thank you very much. I've enjoyed being here.